The immobilization have some of the advantages. Nowadays, the immobilized enzymes are used in various industries because due to these advantages. Let's look at the advantages of immobilizing enzymes more broadly. The first and foremost advantage is reusability. Immobilized enzymes can be reused multiple times, which significantly reduces the cost of enzyme usage in industrial processes. Stability. Enzyme mobilization enhances stability, making enzymes more resistant to extreme temperatures, pH changes, and organic solvents. Control. Enzyme reactions can be more easily controlled when the enzyme is localized in a specific area, allowing for greater precision in industrial applications. Continuous processing. Immobilized enzymes allow for continuous reaction processes, which is ideal for large-scale industrial applications. However, there are some disadvantages to enzyme immobilization that need to be considered. Decreased activity. Sometimes immobilization can reduce the enzyme's activity due to steric hindrance or loss of flexibility in the structure. Cost. The process of immobilizing enzymes can be expensive, especially if complex techniques or specialized equipment are involved. In conclusion, enzyme immobilization is a powerful tool in biocatalysis and industrial biotechnology. It allows enzymes to be reused, increases their stability, and enables more efficient control of biochemical reactions. While each method of enzyme immobilization has its own advantages and challenges, the selection of the appropriate method depends on the specific requirements of the application. Thank you for your attention. I hope this presentation gave you a deeper understanding of enzyme mobilization and its importance in industrial and biotechnological applications. Next, we move on to a fascinating area of nanotechnology and food biotechnology is nanoenzymes. Nanoenzymes, a new generation of artificial enzymes with highly effective enzyme-like properties, which have come into focus and have achieved great progress. The nanoenzymes, these are synthetic nanoparticles that mimic the catalytic activities of natural enzymes. Unlike traditional enzymes, Nanoenzymes are engineered material that can perform similar biochemical reactions but with unique advantages. Let's dive into the key features of nanoenzymes. First, they mimic the functions of natural enzymes. Natural enzymes play vital roles in countless biological processes, and nanoenzymes can replicate these functions, such as speeding up biochemical reactions. Second, nanoenzymes have catalytic activity, meaning they can accelerate chemical reactions without being consumed in the process. Just like natural enzymes do. One of the most significant advantages of nanoenzymes is their ability to withstand a stable environment, which is nothing but the stability and durability. While natural enzymes are sensitive to temperature, pH, and environmental conditions. Nanoenzymes are typically more stable, making them more versatile and practical for various applications. Finally, the large surface area of nanoparticle provides multiple active sites for catalytic reactions, which can significantly enhance their efficiency. And these are the key functions which I have discussed earlier. They mimic the functions of natural enzymes. They play a vital role in countless biological processes, and nanoenzymes can replicate these functions, such as speeding up of biochemical reactions. They have catalytic activity, meaning they can accelerate the chemical reactions without being consumed in the process, just like natural enzymes do. One of the most significant advantages of nanoenzyme is their stability and durability. Unlike natural enzymes, while natural enzymes are sensitive to temperature, pH, and environmental conditions, nanoenzymes are typically more stable and can function under harsher conditions. Finally, the large surface area. The nanoparticle provide multiple active sites for catalytic reactions, which can significantly enhance their efficiency. And this is what is a nanoenzyme. The nanoenzyme has more advantageous than the normal enzymes, because they can mimic the functions of natural enzymes, and the bio-inspired nanoenzymes, they can mimic, and they can also have a catalytic activity, since they are bio-inspired nanoenzymes. They have more significant stability and durability, and also the surface area have multiple active sites. So this becomes nanoenzyme has more significantly is used, and it has enhanced their efficiency. And if you look into the applications of nanoenzyme, can be used in various industries such as cancer treatment and in the biocatalysis industry, elimination of pathogens, and the neuroprotection industry, enzyme inhibition, and biosensing. And some of the other uh, applications which include in the various fields. And just talk about the exciting applications of nanoenzymes in the biomedical field. Nanoenzymes can be used for disease diagnosis, the treatment, and drug delivery systems. It also has some of the environmental protection in and they hold, and in the biomedical field they hold great promise in biosensors, helping detect biomarkers for diseases like cancers. In environmental protection, nanoenzymes can assist in breaking down pollutants and toxic substances, offering a sustainable solution to waste management and environmental cleanup. In food and agriculture, nanoenzymes are being explored for enhancing food safety by detecting contaminants, and they can also help improve agricultural productivity by enhancing nutrient absorption in plants. There are many types of nanoenzymes. The types of nanoenzymes are metal nanoparticles, and how they are classified. And they are typically classified by the materials used to create them. For example, metal nanoparticles. These metal nanoparticles, these nanoenzymes, can mimic the activity of natural enzymes like peroxidases, catalase, or oxidoreductases. The peroxidases mainly they act on peroxides molecule. The catalases they mainly act on hydrogen peroxide, and they catalyzes the reactions and forms into H2O and oxygen. And oxidoreductases they play major role in redox reactions. There are several metals which act as the cofactors, and these cofactors are very important for enzyme activity. The carbon-based nanoenzymes. Materials such as graphene oxide and carbon nanotubes have been found to exhibit enzyme-like activities. These are often used in advanced sensing technologies. We have polymeric nanoenzymes. The polymeric nanoenzymes are made from synthetic polymers and are particularly useful in drug delivery and biocatalysis. Like I said, the metal nanozymes or nano enzymes, they are nano-sized material, the nano size, the nanozyme and enzyme. So in short, nanoenzymes represent a promising and growing in nanotechnology with a wide range of potential applications across multiple fields, from medical diagnostics to environmental protection. They offer enhanced stability, efficiency, and versatility compared to traditional enzymes. As research in this area continues to grow, nanoenzymes could become key players in solving some of today's most pressing challenges. Therefore, these nanoenzymes, also known as nanozymes, are nanomaterial that mimic the catalytic functions of natural enzymes, unlike traditional enzymes, which can be sensitive to temperature, pH, and other environmental conditions. They are generally more stable, easier to produce, and cost effective. They have been widely explored for applications of biosensors. Like I said, when I said the applications in the biosensor, due to their high stability, catalytic efficiency, and low production cost compared to natural enzymes. In biosensors, nanoenzymes can replace traditional enzymes to catalyze specific reactions, generating measurable signals such as color changes, the fluorescence, or electrochemical outputs. This enhances the sensitivity, selectivity, and durability of the sensor. And where it is used, the nanoenzyme coupled biosensors are commonly used in glucose monitoring, detection of pathogens, and environmental pollutant sensing. Like I said, the popular enzymes which are used to make nanoenzymes in biosensors are metal oxides, noble metal nanoparticles, and carbon-based nanomaterials. And where generally the nanoenzymes are used in food. They mainly offer promising solutions for improving food safety, quality, and shelf life monitoring. Their enzyme-like activity can be used to detect harmful contaminants such as pathogens, pesticides, or toxins through a rapid and sensitive biosensors. Nanoenzymes can also be incorporated into smart packaging. This is something and additional applications of nanoenzymes in incorporation into a smart packaging. This indicates spoilage by reacting with gases or metabolites released by deteriorating food. Additionally, they have a potential use in food processing. For example, aiding in the breakdown of complex molecules to enhance nutritional content or flavor. Their stability and low cost make them ideal for practical real world food industry application. And where it is used, the nanozyme in smart packaging play a crucial role in enhancing food safety. And these nanozymes can be integrated into packaging material to detect spoilage indicators such as changes in pH, temperature, or the presence of specific gases. For example, ammonia, hydrogen sulfide released during food production. Upon detecting these changes, the nanoenzyme can trigger a visible signal such as a color change, alerting consumers to potential spoilage. Their high stability, sensitivity, and reusability make it an ideal for intelligent packaging system, which also aim at reducing food waste and ensuring food safety. In short, nanoenzymes represents a promising and growing area in nanotechnology with a wide range of potential applications across multiple fields. Thank you for your attention. I hope this presentation gave you a deeper understanding of nanoenzymes and its importance in industrial and biotechnological application. Now, I would be happy to answer any question or discuss any points in more detail. Thank you one and all.